Okay, next up we have the extreme value theorem. This will be a very quick video. The extreme value theorem, and again, you can see it in the middle of the sheet that you have in front of you, basically says that if you have any continuous function, and that's our hypothesis, again, you're looking at here, if a function f is continuous on a closed interval. So we got a continuous function on a closed interval. The extreme value theorem, what that's saying on that sheet right there, is basically that f, that function, is going to have a highest point, and it's going to have a lowest point. Right? Remember from earlier in the year, we call a highest point an absolute max, we call the lowest point the absolute min. So on a closed interval, a continuous function is guaranteed to have an absolute maximum value and an absolute minimum value. That's what the extreme value theorem says. Nothing more. Okay? Doesn't tell us where the absolute max is, doesn't tell us where the absolute min is. Remember, that's what our candidates test does. All right, this is one of those things where we actually learned where to find the stuff before we actually learned the theorem. But the theorem itself just says, guess what? You got a continuous function, there's going to be a highest value, and there's going to be a lowest value. Where they are, that's your problem. You got to figure it out. And of course you can, but the theorem doesn't help us find it. Okay? So again, we're looking at this function right here. We've got a continuous function. Here's A, so I'll just section that off, and here's B. And basically, all that the theorem says is somewhere between here and here, there's going to be a highest value and a lowest value. All right, now we can clearly pick out the lowest values right there, and that's what it's talking about when you see the whole f of c is less than f of x. This is basically identifying that point right there as c. There is no point in between a and b which is lower than the function's value at x equals c. Okay, here's all the f of x. All right, that's the f of c. F of c is the smallest value. It's the absolute min. Okay, then we look for the absolute max. Well, we've got a choice there or here, but it looks like the absolute max actually occurs right there. That, what you see on your paper, is the letter D. Okay, that's the absolute maximum value. There is no value of the function in between a and b which is greater than the value of the function at x equals d. Okay, this is the highest possible value. It's the absolute max. The extreme value theorem guarantees that it exists. All right, so often when I give this, and maybe you're thinking about this right now, you're thinking, well, wait a minute, what about this function right here? All right, so here's my a, here's my b, and here's my function. Okay, f. F is the horizontal line. F is the function y equals 6. Okay, well, where's the absolute max? Where's the absolute min? Because there's my interval in which I'm interested, and where's the highest value? And the answer is, they're all the highest value. That's your D right there. Or perhaps that's your D right there. They're all the same value, but they're all the highest value. There is no spot on the graph larger, higher, greater than that value right there. So that could be our D. Okay? Now, coincidentally, that value is also our C. Or it could be this value as our D and our C. Or maybe that's our C over there, and this is our D over there. They're all the same values. The extreme value theorem doesn't say that there's only one spot where this highest point is. It just says that there is a highest point. And in this case, all the points are the highest point. Okay? So it's guaranteed, though, that there is definitely a point that there is nothing. That's why, again, you see the whole less than or equal to, greater than or equal to on that spot. You can't get bigger than that point. You might be equal to that point, but you can't get bigger than that point. You can't get less than that point. And again, if you got yourself a horizontal line, then all the points are the absolute max and the absolute min. Okay, but the extreme value theorem just guarantees that there's a highest value and a lowest value. Doesn't guarantee how many. More if there's more than one, just says it's going to be at least one highest value and one lowest value. It doesn't tell us where it is, just guarantees that it exists.